Assalamualaikum and good day everyone. So as for today, we are going to start with our online learning. So this is one of the lesson that we are going to go through. Okay, and I will start with the recap of the online exercise that we have go through via Google Classroom before the PKP. Right, so if you can see here, what I'm going to do here is just to recap back, okay, as for you to memorize back what we have go through previously, okay, which is with regards to the pre-stressed concrete design, okay, whereas we have learned on a few equations that we can derive from the stress block of a pre-stressed concrete section. So what we have go through previously is that I have shown you how to derive the equations, okay, which are for two types of members. Okay, one is for a member without eccentricity and another one is for members with eccentricity. Right, so as we can see here for the online exercise that I have asked you to do previously, okay, is that we have a different cross section, okay, and you are required to calculate the top and bottom stresses, okay, which is for the simply supported beam, and you will also be required to sketch the final stress distribution of the beam. So you can see here, this is the cross section, okay, of the beam, okay, at our left. Okay, so this is the cross section. So you are given the height, the width, and also the width of the flange, okay, of this section, and you are also given the longitudinal view of this section. So you can see here we have a simply supported beam, okay, which spans 12 meters, and it is a post tension pre-stressed beam, okay, by a single cable with 0 eccentricity at the ends, and also 250 eccentricity at midspan. Right, so as you can see here, we are going to have two different values of stresses, okay, which is for the end span and also for the mid span. Right, so the pre-stressing force in the tendon is assumed to be constant along the length of the beam with a magnitude of P equals to 1760 kilonewton. Right, so this is the value of the pre-stress force, and together with this question, we have already been given the value of the second moment of area, K or I, K or moment, or also known as the moment of inertia, already calculated, which is 20 times with 10 to the power of 9 millimeter to the power of 4. Okay, and the location of centroid is also given, okay, which is 415 millimeters from the bottom of the beam. So as what I have already mentioned to you earlier, right, this value of I, okay, and also the location of centroid can be calculated manually, right, okay, so that you can determine, okay, the values, okay, for these two parameters. Okay, so next we move on to the solution. Right, so as what we have go through previously, okay, in view of the equations, right, so we have the values of the moment. Right, so as for this question, we are going to go only for moment maximum, okay, whereas we are going to consider the value of load that is given here, that is already inclusive of the self weight. Right, so we have 30 kilonewton per meter, okay, as for the calculation for moment maximum. So you can see here, since it is a simply supported beam, right, therefore the equation will be only the normal equation of WL squared over 8. Right, so we have here 550 kilonewton meter. Right, and based on the question, okay, we have this information, okay, whereas we have the eccentricity at midspan is 250, then P is equals to 1760 kilonewton, okay, and also we can also calculate the area. Right, so if you still remember in the equation, okay, we have the value of A, okay, that is required to be used. Right, so this is the cross section, okay, and based on the cross section also we can calculate the values of section moduli, right, or section modulus. So we have this equation of Z over T, ZT and also ZB. So we have IY and IY for both equations. Okay, so firstly, okay, you can see here from the question, okay, is that we have already been given the centroid location, okay, which is measured from the bottom of the beam, which is 450 millimeters. Alright, so based on this value, okay, we can calculate the YT value, okay, which is 485. Okay, so this is from the centroid to the top of our beam. Alright, so once we have YT and also we have YB, then we can calculate the value of ZT and also ZB. Right, so based on these equations, these values, okay, then we can proceed with the equation. So we have here, we are going to calculate for the value of the stresses at mid-span first. Right, so this is the equation. Right, so I suppose you can still remember, okay, these equations, okay, whereas we have the equation that is for P over A, okay, which is for the beam itself, okay, and then we plus that up, okay, with the stresses that is due to the eccentricity, okay, and also we have M max over ZT that is due to the bending of our beam. Right, so this is the equation. Right, so what you can do here is that you can substitute all the values, okay, that we have gathered from the question. Right, so we have this part, okay, which is for P over A. Right, then we have moment maximum over ZT, okay, and also we have this part for the in consideration of the eccentricity. Right, so we have come to a total of 8 plus with 13.09 minus with 0.67, so we have here 10.42. Right, so the next one, okay, is for the stress at the bottom of our beam. Right, so there is some difference, okay, between these two values, okay, whereas you can see here, okay, that the value of ZT is different. Okay, as compared to the equation, to the example that we have go through previously, okay, is that we have only considered a rectangular section. So if it is a rectangular section, therefore the centroid sits right in the middle of the beam. Right, so therefore as for that case, okay, we are going to have similar values of Z. But as for this question, since we have different values of Y, okay, whereas the centroid is sitting here, okay, not in the right in the middle of the beam, okay, so therefore the Z value will be different. Right, so we can see here we have 41.24 and also we have 48.19. Right, so here at mid-span, okay, with the eccentricity of 250, we can see that we have the stress at the on top of the beam is 10.42 and the stress at the bottom of the beam is 5.92. Right, okay, so this is for the mid-span. So next we move on to the end span. Right, so as what we know, okay, when we talk about end span, okay, and in the question it also has been stated, okay, that the eccentricity value at that point is equal to 0. Right, so it sits right exactly at the um, centroid of the section. Okay, then we also know that at the end span, okay, we are going to have moment that is equal to 0. Right, so therefore we are going to use the similar equation that we have used previously, and we are going to cancel out, okay, a few values, okay, which are the moment values at the moment equation as well as the one that have the eccentricity value. So we have M max, okay, equal to 0 and also PE equals to 0. Right, okay, so by substituting the values, so we are left with only P over A. Right, so similarly, okay, for the second equation, okay, which is for FB, okay, which is for the bottom part of our beam. Right, so here we also have 8 Newton per millimeter square. Right, so we are going to have two similar values, okay, since the values that we have here no longer considers the value of Z. Right, okay, so the last part of the exercise, okay, is that you have to plot, okay, the stress distribution of the beam. All right, so you can see here this is the stress distribution at mid-span. Right, so we can see that we have P over A, which is due to the pre-stress force, then plus minus with 13.09, okay, which is on the top part. Right, so we know that for this part, okay, when we talk about uh, uh, this part, all right, so therefore we are going to consider this value, the top value, as negative 13.09. Right, then plus this value with 10.67. Right, so therefore we have 10.42. All right, so this is the total or final value. All right, then this is for the stress distribution at mid-span. So we have 8 plus with 11.21 minus with 9.13. Right, so we have 5.92 for the bottom part of the beam. Right, Then this is the stress distribution that is at midspan, right? So since we are not going to have any effect of the moment and also the eccentricity, so therefore we are left with only 8 Newton per millimeter square. That is due to the pre-stress force. All right. So I suppose that will be the end of this explanation, right? So you can check this answer, okay, with the answers that you have already given me in the Google Classroom, right? So you can check and you can make corrections, okay, on whatever calculation that you have carried out previously. Okay, right? So thank you. And make sure you fill up the attendance form that I will attach later, okay, in the Microsoft Teams. Thank you.